Hello everyone, myself Naresh H, Assistant Professor, Department of Mechanical Engineering, SIT, Tumakuru. First of all, I would like to welcome you all to today's session. We will be focusing on solving a static structural problem of a stepped bar using Ansys Workbench. So let's start. This is the problem statement. Determine the total deformation and maximum stress for stepped bar subjected to point load with boundary condition as shown below. Take Young's modulus as 70 GPa and 200 GPa for material 1 and 2 respectively. Diameter of section 1 is 55 mm and for second section is 27.5 mm. Poisson ratio for material 1 as 0.32 and for material 2 as 0.3. So this is the stepped bar given. So this is completely material 1 having an Young's modulus of 70 GPa and diameter is 55 mm, length is 800 mm. This is completely material 2 having Young's modulus 200 GPa, diameter 27.5 mm and length is 600 mm. Both ends of a stepped bar is fixed and the intersection of bar 1 and bar 2 is subjected to a point load of 200 kN. So here we want to find the total deformation and maximum stress of this stepped bar using Ansys Workbench. So let's begin. So when you open the Ansys Workbench, this is the first window it will pop up. So in the left side, the toolbox, you can see the different analysis systems it has. So based on the problem statement, you need to select the method to solve your problem. As in this case, this is a static structural related problem. I am going to select this static structural, drag it and leave it on the screen. So just rename this as stepped bar. Next, engineering data, right click, edit. So here you can see some of the standard materials which is already updated in the engineering data sources. If some materials properties has not been updated, then you need to add a new material and then you need to add the properties of that material. So in this case we have two materials, material 1 and material 2. So its Young's modulus is 70 GPa and 200 GPa. So we need to create the new materials. And one more important thing is here, if you are not unable to see any of the toolbox or any of the window over here, so just go for view, reset workspace and again go for view and reset window layout. So this is very important. If you are unable to see any of the toolbox or any of the window, you just click on these two icons. All the toolbox closed will be retrieved and the window layout will be in its position. So now click here to add new material. So type it as material 1, mat 1 and again new material, mat 2. So again click on mat 1. So as it is isotropic elastic material, click and drag it on mat 1. So Young's modulus, change this to megapascal. So its Young's modulus is 70 GPa, so 0.75. So its Poisson ratio is 0.32. Again click on mat 2, isotropic elasticity, repeat the same procedure, change this to MPa. Its Young's modulus is 2E5, Poisson ratio is 0.3. So now two materials has been added to this engineering data source. Now go back to your project workbench, right click on geometry, click on new design modeler geometry. Now select XY plane, look at face, change this to millimeter. Don't forget to change these units from meter to millimeters. Next go for sketching. So go for circle, create the circle from the origin, go for dimension, general, select the circle, click on the screen. So diameter 1. So this diameter is 55 mm. Change this to 55 mm. Next click on extrude. This geometry has been selected by default. Click apply. So its depth is 800 mm. Change this to 800. Next click on generate. Zoom out. Next select this faces. Click on this face. Look at face. You can zoom in. Go for sketching. Select circle with the same center. Create one more circle. Go for dimension. Click on the circle and click on the screen. So this diameter is 27.5 mm. Change this to 27.5 mm and again extrude. Second geometry apply. Next its depth is 600 mm. So change this to 600. Next click on generate. So you can see the second bar over here. Next click on extrude 1. Operation, by default it will be selected as add material. Again select extrude 2. Operation, change this add material to add frozen. The reason is, if you are having a stepped bar like this, if you want to establish a relation from stepped bar 1 to stepped bar 2, then you need to select it as add frozen for the second bar, or else there is no continuity from bar 1 to bar 2. So if you forgot to do this, your answers will vary. Don't forget to change this to add frozen and click on generate. So now you can see the second bar is in the transparent mode. So go back to the workbench, double click on the model. So your model has been imported successfully. So this is the project tree. You can see, just click on the geometry and click on the solid. As we have two materials here, software will not understand which is material 1 and which is material 2. So you need to assign the materials. To do that, click on first solid, change this assignment to mat 1, and again click on second solid, change this to mat 2. So now go for mesh. So just click on mesh, element size default. If you want to define the element size, you can specify the value over here, or else system will calculate on its own and it will perform the meshing. So right click on mesh, just click on generate mesh. So meshing is done. So next I want to define the loads. Click on static structural, right click, insert, fixed support. So click on this face, select this face, apply. So rotate this, repeat the same procedure, insert, fixed support, select this face, apply. So next I want to apply load at this interface. To do that, first I will right click on second bar and suppress body. Now you can see the face clearly. So go for static structural, right click, insert, apply force, select this face, apply, change this vector to components. Now you can see three directions, X, Y and Z. So you can see the direction in which load has to be applied in the compass. So it is in the Z direction. So change this to, so the value is 200 kilonewton. Change this to 200 E3. So next go for geometry. So here you can see the into mark, means we have made the body to suppress. So now I will right click on this, I will unsuppress this body. So we will get back the model. So all the loads has been defined. Now right click on the solution, insert, deformation. I want to find total deformation. Right click on solution, insert, I want to find the maximum stress. So again right click on solution, solve for this. will take some time. So here you can see your solution is ready. You just click on this total deformation. So here you can see the total deformation. 0 is the minimum, which is indicated in blue color, and this is the maximum value, which is indicated in the red color. So you can play the animation over here and again click on equivalent stress. So this is the minimum value and this is the maximum value. So if you want to print the report, just click on report preview. So your report will be generated. So this can be printed or this can be shared. Okay, so that's all for today's session. Thank you. See you in the next video.